Okay, these four problems involve determining what the limiting reactant is. And remember, the limiting reactant limits the amount of product that can be made. So the reactant that produces the least amount is the limiting reactant. And how we're going to set it up is we're going to take each reactant, figure out how much product can be made from each reactant, choose the smaller number. The substance that produces that smaller number, that's our limiting reactant. And we are always going to be given limiting reactant problems mole to mole. We're not even going to make it any more complicated. So let's start by going C2H4 to a product. Now we have two products here. It doesn't matter which product we use. We choose one. So I have decided to go to this carbon dioxide. So I'm going to go from 2.7 moles of C2H4. I'm going to put it over 1 mole C2H4 to mole CO2. Now I have a 2 next to the CO2 and I have a 1 next to C2H4. So I can make 5.4 moles if all the C2H4 is used up. Now I have to see, well, if all of the oxygen is used up, all 6.3 moles, how much CO2 can I make? So moles of oxygen comes down. Now I have to go to the same spot, so I'm still going to go to moles CO2. I have a 2 in front of CO2, and I have a 3 in front of the oxygen. So now what I can make is 4.2 moles of CO2. So the one that makes the smaller amount, that's the 4.2 moles. So therefore, my limiting reactant is my oxygen. And then my excess reactant is the C2H4. Okay, the second example, same thing. I'm going to figure out how much product I can make from the Sb2S3 and how much I can make from the iron. I have chosen to go to the antimony, but you could just as easily go to the FeS. You're going to get the same answer as far as identifying limiting reactant. So for the first time, we're going to go 15 moles of Sb2S3. I'm going to bring moles Sb2S3 down, and I'm going to go to moles of Sb. I have a 2 next to Sb. I have a 1 next to Sb2S3. So I can make 30 moles of Sb if all of the Sb2S3 is used up. Now for the iron, I have 10.5 moles of iron. Put it over 1. Moles of iron comes down. I want to go to moles of Sb. I have a 2 next to Sb and a 3 next to Fe. And so if all of my iron is used up, I'm going to get 7 moles of Sb. My smaller amount is the 7 moles. Therefore, my limiting reactant is the iron. Okay. Third example, we're doing exactly the same thing. This time we only have one product. So I have 10 moles of aluminum, and I want to go to aluminum chloride. So moles of aluminum comes down. Moles of aluminum chloride goes to the top. I have a 2 next to the aluminum chloride and a 2 next to the aluminum. So if all the aluminum is used up, I can get 10 moles of aluminum chloride. Now we're going to use 10 moles of chlorine. So 10 moles of chlorine. Moles of chlorine comes down. And then I go to moles aluminum chloride. 2 is next to aluminum chloride. 3 is next to chlorine. And so if all of the chlorine is used up, I get 6.7 moles of aluminum chloride. That's my smaller number. So again, the smaller number is what determines what my limiting reactant is. So my limiting reactant here is chlorine. The last example, we have lithium nitride reacting with water. We want to know what the limiting reactant is. Again, we can choose any product. I chose to go to the NH3. So let's start with water. We have 9 moles of water. Moles of water comes down, and I'm going to moles of NH3. I have a 1 next to NH3, a 3 next to H2O. So if all the water is used up, I have 3 moles of NH3 produced. Now I have 4 moles of Li3N. Moles of Li3N comes down. I'm going to go to moles of NH3. Again, 1 next to NH3, 1 next to Li3N. Therefore, if all of my Li3N is used up, I have 4 moles of NH3. The smaller number is what's going to tell me what my limiting reactant is. The smaller number is 3 moles now. So therefore, my limiting reactant is H2O.